I'm Stephen Darby and I work as a researcher here in the Centre for Advanced Photonics and Process Analysis, or CAPA, in Munster Technological University. CAPA is an Enterprise Ireland technology gateway working mainly on industry-focused projects in the pharma, medtech and food sectors. I was involved in NSAI Swift 19. I was a technical advisor on SENS CWA 17553 and I now chair NSAI Technical Committee number 67 on community face coverings. Early in 2020 we applied for funding from Science Foundation Ireland as part of their COVID-19 rapid response call, and our aim was to investigate what types of masks were most effective. By summer 2020 a lot of work had already been published on mask materials, but very little work had been done on mask fit. And that's because it's not straightforward to measure fit for these types of mask, and in fact there's no established measurement for outward leakage. As a solution, we developed a technique using a curved laser sheet to visualize leakage from around the whole face. This research is informing the tests that are being included in the upcoming SEN technical specifications, and it will also inform any future standards that are developed for masks. The research being conducted by CAPA and the NSAI committee members around Ireland is filling a gap in measurement techniques for standards, especially for newer designs of face masks that make life easier for people with disabilities. This research will eventually lead to better masks for all, and contributing our findings to standards can accelerate its seamless adoption by industry.
I'm Kevin Nolan. I lecture at the School of Mechanical and Materials Engineering at University College Dublin. I specialise in experimental fluid mechanics and optical techniques, including particle image velocimetry and Schlieren. These allow us to see the flows of particles that are otherwise invisible to the human eye. Since the start of the pandemic, I have been collaborating with surgeons at the Mater Misericordiae University Hospital to better understand how aerosol and smoke generation can be mitigated during laparoscopic surgery, otherwise known as keyhole surgery. During the project, it became apparent that the techniques I use would also be suitable for evaluating the effectiveness of face masks, and so I started working with colleagues at NUI Galway. Using the same techniques, we have been able to successfully identify the kinds of leaks that can typically occur in community face coverings, a topic that was not previously possible to address in the standard. It has been fantastic to engage with a multidisciplinary team involving academics and students on such important research informing standards development. This standardization work, coupled with ongoing research with the surgical team at the Mater, can have a huge impact on the lives of people in Ireland and in Europe.
Hi, my name is Martina Kelly. I'm a lecturer in Mechanical Engineering at NUI Galway. I'm also very involved in our occupational and environmental health and safety programmes in the College of Science and Engineering. With my colleagues, Marie Coggins, Gerard O'Connor and Alan Keneally, we represent staff working in areas such as exposure science, ergonomics and laser applications at NUIG. Through the research we're doing, we have been able to show that how PPE is used can have a huge impact on the wearer's risk of exposure to harmful substances. If a respirator doesn't fit properly, it can lead to contact transmission and higher exposure, for example, to pesticides. We also found that an ill-fitting mask can make the wearer more likely to fidget with the PPE, leading them to inadvertently touch their face and disturb the facial seals on the mask. Our team concluded that these practices can greatly compromise the level of protection given by the mask. To address the problem, we worked to identify how the fit of a facial covering could be improved to provide greater protection. We used methods like the quantitative respirator fit test, typically used in occupational settings, as well as 3D scanning of facial anthropometry. We created design modifications based on these findings and were able to test our prototypes using a Schlieren gas flow visualization system with a mannequin head and a representative respiration circuit. After a 3-week period of intensive testing and modifying, we created new mask design features which improved fit. By getting involved with standards, we were delighted to put our project outcomes to use. In committee meetings, we had the chance to bring our findings to the table, which informed last year's SWIFT 19 specification. After that, we rapidly developed our research when we had the opportunity to work with NSAI and SEN's working group on community face coverings. As a multidisciplinary team, we are proud to create a positive scientific and societal impact with our work. Thank you.